Hello friends, I welcome you in lecture number 20 on graph theory. In this lecture we will discuss connectedness in directed graphs. So far we have discussed connectedness for undirected graph and now onwards we are going to discuss connectedness in directed graphs. So in undirected graph, if we recall that if we have a graph G, then graph G is said to be connected if for every pair of distinct vertices there is a path between them, or graph G is connected if for any pair of vertices one node is reachable from the other. That was the definition of connected graph for undirected graph. That is, if we take any two distinct vertices in a given graph, then there is a path between them. But for directed graph, it is not necessary that if there is a path from U to V, then there is also a path from V to U. So for directed graph, the definitions are different for connectedness as compared to undirected graph. In undirected graph, we have only one definition, that is connected graph, and we say that graph G is connected if we take any two vertices from that graph, then there is a path between those two vertices, or those two vertices are reachable from each other. But for directed graph, we are going to discuss three definitions. First definition is a weakly connected directed graph. Weakly connected directed graph or weakly connected diagraph. So a directed graph, say G equal to order pair V comma E, is said to be weakly connected if it is connected, if we consider it as undirected. A directed graph is said to be weakly connected if the underlying undirected graph is connected. That is, if direction of edges are neglected, then we will obtain undirected graph, and if that undirected graph is connected, then we say that given directed graph is weakly connected. For example, if I consider this graph, suppose I have this graph and this is directed graph because all the edges are directed edges. Now if we ignore the directions, then we will have this underlying undirected graph. This is the undirected graph corresponding to this directed graph, in which we neglect the directions of edges. Suppose vertices are denoted by V1, V2, V3, V4. Here also V1, V2, V3 and V4. So after neglecting directions of edges in this directed graph, we have this underlying undirected graph, and then we check whether this undirected graph is connected or not. If this graph is connected, then corresponding directed graph is called weakly connected directed graph. Now here it is easy to check whether this is connected or not. We can see that there is a path between V1 and V2. Similarly, there is a path between V1 and V3 as well as between V1 and V4. There is a path between V2 and V3 and V2 and V4, and similarly there is a path between V3 and V1, V3 and V2, V3 and V4, and also there is a path between V4 and V1, V4 and V2, and V4 and V3. Therefore this undirected graph is connected undirected graph, and therefore this directed graph is weakly connected directed graph. So a directed graph is said to be weakly connected diagraph if the underlying undirected graph is connected if the directions of edges are neglected. That is the meaning of weakly connected directed graph. Now once you understand weakly connected directed graph, we have another definition which is called unilaterally connected directed graph. Unilaterally connected directed graph. So a directed graph is said to be unilaterally connected if for any pair of nodes, here we have directed edges, if for any pair of nodes in the graph at least one of the nodes is reachable from the other. That is, if I take any two nodes in the directed graph, then either there is a path from U to V or there is a path from V to U. If we take any pair of nodes of the graph, then at least one of the two nodes is reachable from another node. That is, if we take any two nodes in the directed graph, then there is a path from U to V or there is a path from V to U. In other words, at least one node is reachable from the another node. So if this condition is satisfied, then we say that a directed graph is unilaterally connected. So we can check here whether this is possible for each and every pair of this graph. First I will check for this pair V1 and V2. So I have to check whether either one vertex is reachable from the another vertex. So we can see there is a path from V2 to V1. So V1 is reachable from V2. Here you can notice that V2 is not reachable from V1. But if at least one node is reachable from the another node, then that is allowed. So for V1 and V2, we have a path from V2 to V1, that is V1 is reachable from V2. Similarly, we check for V1 and V3. So here also V3 is not reachable from V1, but you can see V1 is reachable from V3. There is a path from V3 to V1. So V1 is reachable from V3. Similarly, we can see that V1 is reachable from V4 also. So that is also satisfied. Now we check for V2 and V3. So obviously V2 is reachable from V3. So that is also satisfied. Similarly, we have to check for V2 and V4. So there is a path from V4 to V2. Therefore V2 is also reachable from V4. And then we check for V3 and V4. So here also V3 is reachable from V4. And then we check for V4 and V1 is already there. V4 and V2 is already there, and V4 and V3 is already there. So we have seen that for any two distinct nodes in this directed graph, at least one node of the pair is reachable from the other node. Therefore, this is an example of unilaterally connected directed graph. And the next definition is strongly connected directed graph. What is meaning of strongly connected directed graph? So here it is required that if we take any pair of nodes, then there is a path from U to V and there is a path from V to U. That means for any pair of nodes, both nodes are reachable from one another. So for this, if we check for this pair V1 and V2, then here we have seen that V1 is reachable from V2, but V2 is not reachable from V1. Therefore, this graph is not strongly connected directed graph. It is unilaterally connected directed graph, but it is not strongly connected directed graph, because for strongly connected directed graph, we require that U is reachable from V as well as V is reachable from U. Both the nodes must be reachable from one another, or there must be a path from U to V and from V to U. For unilaterally connected, we have either a path from U to V or from V to U. But for strongly connected, we must have path from U to V as well as from V to U. So I have written all these definitions here. They ask you to write down the definitions in your examinations, so you should write properly. A diagraph is weakly connected if it is connected as an undirected graph in which the direction of the edges is neglected. In other words, if the graph when treated as an undirected graph is connected, then it is called weakly connected directed graph. This is for unilaterally connected, a simple diagraph. Simple diagraph means graph without parallel edges and loops. A simple diagraph is unilaterally connected if for any pair of nodes of the graph, at least one of the two nodes of the pair is reachable from the other node. Or in other words, if we take any pair UV of nodes in the graph, then either there is a path from U to V or there is a path from V to U. And finally, we can see this remark that if our graph is unilaterally connected, then it is always weakly connected, but converse is not true. That is, if graph is weakly connected, then it is not necessary that it is unilaterally connected, but unilaterally connected graph is always weakly connected. And if for any pair of nodes of the graph, both the nodes of the pair are reachable from one another, then a simple diagraph is said to be strongly connected. In other words, if we take any two nodes from the given graph, then there must be a path from U to V and from V to U. So it is obvious that a strongly connected graph is always unilaterally connected as well as weakly connected. In a diagraph, if it is strongly connected, then it is unilaterally and weakly connected. So here I have taken one graph denoted by G1, and we can see that this is strongly connected. We have to check for each and every pair of nodes. If I take V1 and V2, then from V1 to V2 we have this path, and from V2 to V1 we have this path. If we go from V2 to V1 in this direction, then there is a path from V2 to V1 also. So both the nodes V1 and V2 are reachable from each other. Similarly, we have to check for every pair of vertices. Here we can see that there is a path from V3 to V1, and for V1 to V3 we have to go along this path. If we go along this path, then V3 is also reachable from V1. Then for V1 and V4, so V4 is reachable from V1. There is a path from V1 to V4, this path. And for V4 to V1 we have to consider this path. We start from V4 in this direction, and we are able to find a path from V4 to V1 also. Then we check for V2 and V3. V2 and V1 is already checked. So for V2 and V3, this is a path from V2 to V3, and if I want to go from V3 to V2, I have to consider this path. So there is a path from V2 to V3 as well as from V3 to V2. then I check for V2 and V4. So for we have a path from V4 to V2, that is V2 is reachable from V4, and if I want to find a path from V2 to V4, I will consider this direction. So this is a path from V2 to V4. So V2 and V4 are reachable from each other. Then we have to check for V3 V1, V3 V2, and then V3 and V4. So along this path V4 is reachable from V3, and V3 is reachable from V4 along this path. If we go from V4 along this path, we are able to reach V3. That is, V3 and V4 are reachable from each other. And with V4 I have V1, V2 and V3. So we have checked for all pairs of the nodes of this diagram that for every pair both the nodes are reachable from each other. Therefore this graph G1 is strongly connected, and if it is strongly connected, it is weakly as well as unilaterally connected. Now I have taken this graph. Here also we will check whether it is strongly, weakly or unilaterally connected. So if I check for V1 and V2, we can see that along this path V2 is reachable from V1. But if we check whether V1 is reachable from V2 or not, so if I go from V2, then you can see there is no edge coming out of V2. So we are not able to reach V1 from V2. V1 is not reachable from V2. V1 is not reachable from V2 because there is no path from V2 to V1. Because there is no path from V2 to V1. So we have obtained one pair of nodes V1 and V2 such that both the nodes are not reachable from each other. Here V2 is reachable from V1, but V1 is not reachable from V2. Therefore this graph is not strongly connected. If it is strongly connected, then for every pair of nodes we must have both the nodes reachable from each other. Therefore G2 is not strongly connected. So now we check for unilaterally connected. So for unilaterally connected, we require that at least one node is reachable from the other. So here V2 is reachable from V1. Then we check for V1 and V3. So V3, there is a path from V3 to V1, that is V1 is reachable from V3. Then we check for V1 and V4. So here we get a path from V1 to not from V1 to V4. So we check for V4 to V1. For V1 and V4, if I go in this direction, I am not able to reach V4. And if I want to go from V4 to V1, so we obtain this pair V1 and V4. So we are not able to reach V4 from V1. If I go from V1 to V2 in this direction, but here I cannot go, and here also I cannot go. So V4 is not reachable from V1. And if I go from V4 to V1, then that is also not possible. So we have obtained a pair of nodes V1, V4 such that neither node is reachable from another node. There is no path from V1 to V4. There is no path from node V1 to V4, or and there is no path from V4 to V1. Therefore G2 is not unilaterally connected graph. G2 is not unilaterally connected because we have obtained one pair in which neither node is reachable from another node. We can see that from V4 it is not possible to find a path up to V1, and from V1 also we cannot go along path to V4. Therefore G2 is not unilaterally connected. And for weakly connected, we have to ignore the direction of edges, and as we discussed in the beginning, that this is nothing but weakly connected graph. If we neglect the directions of edges, we obtain this undirected graph, and here it is clear that we can obtain a path from one vertex to another vertex. For every pair there is a path from V3 to V1. Okay, fine. So this is weakly connected. Okay, you can see that if I take any pair of nodes, then they are reachable from each other. V1 to V2, V1 to V3, V1 to V4, then V2 to V1, V3, V4, V3 to V1, V3 to V2, and V3 to V4. Similarly, V4 to V1, V4 to V2. So for this undirected graph, if we take any two nodes, there is a path between them. Therefore this undirected graph is connected, and hence G2 is weakly connected. Graph G2 is weakly connected because it is connected when treated as an undirected graph. Because it is connected when treated as an undirected graph. If we consider G2 as undirected graph, then it is connected, and therefore G2 is weakly connected. So this is the example of a graph which is weakly connected but not unilaterally connected. Remember, if graph is strongly connected, then it is unilaterally as well as weakly connected. If a graph is unilaterally connected, then it is always weakly connected. But converse is not true. We may have a weakly connected graph which is not unilaterally connected, and this G2 is the example of a graph which is weakly connected but not unilaterally connected, as well as not strongly connected. So here I have written all those things that I discussed, and finally we have this graph G3. So you can check as a homework that whether this graph G3 is strongly connected, weakly connected, or unilaterally connected. So this is all about this session. Here we have discussed about connectedness in directed graph, and we have defined three types of directed graphs: strongly connected diagraph, weakly connected diagraph, and unilaterally connected diagraph. So I stop here. Thanks for watching.